Welcome to Elemental Drama, the podcast where the periodic table isn't just memorized, it's exposed. Because behind every element is a history of discovery, controversy, and sometimes destruction.
I'm Sydney, your guide to the electrifying world of chemistry, where atoms don't just bond, but also betray and surprise.
And I'm Kat. Together we dig deep into the real stories of the elements, their uses, their dangers, and their often overlooked roles in shaping our world. Today's spotlight, a classic case of beauty meets danger.
We're talking about arsenic, symbol AS, atomic number 33, known for its infamous role in poisonings, but also for its place in medicine, cosmetics, and even modern tech.
Arsenic's reputation didn't just come out of nowhere. For centuries, it was the go-to poison, tasteless, odorless, and nearly impossible to trace before modern forensics. It became a favorite tool for anyone looking to commit the perfect crime.
In the Victorian era, arsenic was practically a household name, just not in a good way. It was nicknamed inheritance powder because it was so often used to quietly speed up family transitions.
It worked slowly, mimicking the symptoms of diseases like cholera or food poisoning. No suspicion, just a tragic illness. And because it was so easy to obtain, even over the counter, it was terrifyingly accessible.
This wasn't just murder, it was chemistry at work. Arsenic disrupts cellular metabolism by interfering with enzymes, shutting down the body one function at a time.
The irony? Arsenic wasn't just killing people, it was marketed to them. It showed up in face powders, soaps, even health tonics to treat various conditions.
And let's not forget the wallpaper. In the 1800s, green dyes made with arsenic were very on trend. It created stylish interiors that slowly released toxic gases, especially in damp conditions. So yes, that headache you got from your Victorian bedroom, probably arsenic.
The compound most often used was Paris green, copper acetoarsenite. It looked beautiful and it was effective, as both a pigment and a pesticide, just not great for human lungs.
Chemically, arsenic is a metalloid. That means it shares properties with both metals and nonmetals.
It comes in 3 allotropes. Gray arsenic, the most stable and common with a shiny metallic look. Yellow arsenic, highly toxic, unstable, and reactive to light. Black arsenic, rare, brittle, and with a unique layered structure. Each has different properties and behaviors, which is part of what makes arsenic so fascinating to chemists. Despite the drama, arsenic has useful sides. In small, controlled doses, arsenic compounds have been used in medicine, treating diseases like syphilis and even certain cancers.
Arsenic trioxide is still used today to treat a type of leukemia. And in tech, gallium arsenide is a key material in semiconductors, solar cells, and LEDs. It's efficient, fast, and durable under high temperatures.
It's also been studied by NASA. Arsenic-based biochemistry could exist in extreme environments, maybe even elsewhere in the universe, so arsenic's story might not end on Earth.
In the 19th century, arsenic-based pills promised a pale, delicate complexion, the beauty ideal of the time. Women took them hoping for porcelain skin, not realizing they were slowly poisoning themselves.
This is a classic case of toxic beauty standards, literally. Symptoms included hair loss, organ damage, and eventually death, but the illusion of health and purity was strong enough to ignore the science.
It's a reminder, our desire for beauty, power, or health can sometimes blind us to the risks. The same element that once haunted dinner tables now powers lasers and treats cancer.
So next time you hear arsenic, don't just think murder mysteries. Think medicine, innovation, and history, because every element has more than one side.
Thanks for tuning in to Elemental Drama. I'm Sydney.
And I'm Kat.